Hello students. Today we are learning lesson number 8 motion, and we have got some basic idea in the first lecture, the definition of motion and the terms related to it, that is distance and displacement, definition of it. Now today we are trying to learn uniform motion and non-uniform motion. So for that we are taking one example where object A and object B are both are traveling. So the observation of its motion is given here. The data related to it is given in the table. The time t is in minute and the distance traveled by object A and object B is given here in meter. D, that is distance, in meter. So we are measuring the distance in meter unit. So this is the distance traveled by object A and this is the distance traveled by object B. So during the whole observation, the data will be given here. Now, when we start the both is at rest, both starts the motion, both object A and object B. After 5 minutes, when we are measuring the distance traveled by object A and B, object A has traveled 10 meter distance and object B has traveled 12 meter distance. Now, after another 5 minutes, next 5 minutes, at time t is equal to 10 minutes, we can know that object A has traveled 20 meter distance. That means there is an increase of 10 meter, and object B has traveled 19 meter. It means increase of 5 meter. So in this next 5 minutes, object A has traveled 10 meter distance and object B has traveled 7 meter distance. Now, in the next 5 meter, the object A has traveled 30 meter and object B is reaching to 23 meter. In the next 5 meter, object A reaching to 40 meter distance and object B reaching to 35 meter distance. In another 5 minutes, object A is reaching to 50 meter and object B reaching to 37 meter. In the next 5 minutes, that is at t is equal to 30 minutes, object A reaches to 60 meter and object B reaches to 41 meter. So you can observe it at every 5 minutes. Our time interval is very much fixed. Okay, at equal time interval, we are measuring the distance traveled. So you can see that at every 5 minutes, object A is traveling the same amount of distance. At every 5, there is an increase of 10 meter. So in that 5 minutes, object A has traveled 10 meter distance. But object B, in the first 5, it has traveled 7 meter. In the next, it has traveled 4 meter. And in another 5, it is traveling 12 meter distance. In another 5, it is traveling 2 meter distance. And in another 5, it has traveled 4 meter distance. So at each equal interval of time, the distance traveled by the object is not same. Object B is not same. So that defines the uniform. So uniform means equal, right? Regular. Uniform means regular. So we can say that object A is doing a regular motion. That is the uniform motion. So how can we define the uniform motion? If a distance traveled by the object is same in equal interval of time. At equal interval of time, the distance traveled is also same. Then that object we can call it is traveling with a uniform motion, and vice versa. How can we define a non-uniform motion? If the distance traveled by the object is not the same in equal interval of time. Okay, we are measuring, we are observing the motion at equal interval. At equal interval, the distance traveled is not same at every observation, then it is a non-uniform motion. Can we give the example of uniform and non-uniform motion? Can you imagine any object traveling a uniform motion and the object traveling a non-uniform motion? Simply, for a uniform motion, we can say that the vehicle going with a constant speed, right? It means that in a clean and without traffic, if the vehicle is traveling, then that motion of that vehicle will be a uniform motion, and the same vehicle in a traffic road, right? That vehicle will not travel the same distance in every equal amount of time. That object will be a non-uniform motion. And another example, we can see that the motion of Earth around the Sun is uniform motion because it is traveling this equal distance in equal amount of time. The time period taken by the Earth to revolve around the Sun is equal. Okay, so it is traveling the same at equal amount of time. It is traveling the same distance constantly. So that is the uniform motion. The motion of the moon around the Earth, that is also motion, uniform motion. The motion of the hands of a clock, that is also uniform motion. That will be the uniform motion. And for a non-uniform motion, it will be, we can say that, random. The object is traveling with the not traveling the same amount of distance in equal amount of time. That is, so vehicle in a traffic road, that is a non-uniform motion. Now, when objects are traveling, how can we say that how fast the object is traveling? When the object is in motion, here two objects are in motion. Can you say that which object is faster than the other? We cannot say it. To get that idea that when object A is a faster object or B is a faster object, okay, to get how fast the object is, we can define its speed, right? So rate of motion, we should know that to compare how fast different objects are. Okay, so for that, the rate of motion, for the rate of motion, we are trying a very important quantity, that is speed. How can the speed is defined? The definition of speed is the distance traveled by an object in unit time is called its speed. So from the definition, the formula of the speed can be written as here. So V is a symbol for speed. Speed V is equal to distance traveled upon time taken. So the distance traveled by unit time is called its speed. V is equal to by T. And unit of speed. What do we mean by unit? And how do we measure speed? Like distance is measured in meter, kilometer. So meter and kilometer are its units, right? Then time is measured in second, minute, hour. So second, minute, hours are the units for time. Then mass is measured in kilogram. So kilogram is a unit for mass. Same way, we should, if we want to measure the speed, then some unit of the speed should be there. So what will be the unit of speed? Wherever, uh, whenever we need the units can be obtained from its formula. So speed is equal to distance upon time. So unit for speed will be distance is measured in meter and upon time is measured in second. So unit of the speed will be meter per second. Okay, how do we read it? Meter per second. And if this second in denominator goes to numerator, the power becomes negative. So it is also written as meter second inverse. Okay, the meaning is same. Okay, if the denominator goes to numerator, the power becomes negative. That is meter second inverse. So this is the unit for speed. Okay, so if the distance traveled by the object in unit time is a speed. Now understand this. If I ask you that when you are going from home to school, and if I ask that at what speed have you traveled during this, can you say a single speed that I have traveled with this speed during the whole motion from home to school? Definitely no. From home to school, your speed is varying. During in a streets, there is in a street your speed will be less. Then on a highway your speed will be more. At a traffic area your speed will be decreased. So your speed is not same during the whole motion from home to school. So if I ask you that tell me a single number, tell me a single speed that you have traveled during the motion when you are coming to the school. Simply you cannot say a one number. So and still if I'm asking you, would you say the all the numbers that at near the home I have traveled this speed, then at highway I have traveled this speed, then at on this area I have traveled this speed? No, you will not say all the speeds. Okay, so to get rid of this, uh, for a this you have traveled non-uniform motion, in which the speed is not constant during the motion. So for a non-uniform motion, how can we define speed? Then what you will say? We are defining average speed. You will say that I have traveled 40 kilometer per hour. Right? 40 kilometer per hour, it means that your speed will be around the 40 kilometer. At some region, your speed will decrease. At some area, your speed will increase. But averagely, you have traveled 40 kilometers. So I'll understand that. So you are telling your speed by taking the average. Average speed we are always giving. So the average speed, that is VAV, AV means average. Average speed can be defined as the total distance traveled upon total time. Take the total distance from home to school, divide by the total time you have taken. Okay? So that calculation will give the average speed from home to school. Okay? That includes all your variation in the speed. At some region you have decreased your speed, at some region you have increased. But averagely you have traveled with that definite speed. Okay? And units of the speed is meter per second. That is the standard unit, because standard unit of the distance is meter, and for time standard unit is second. So the standard unit is meter per second. Instead of that, there are many different units also possible. If we measure the distance in kilometer and time in hour, then it will be kilometer per hour. Then meter per minute, kilometer per second, meter per minute, meter per hour. So in the new denominator, that is a distance unit, and at the on the numerator it is distance unit, and at the denominator it is time unit. All that units can be of speed. Okay, not just this, various units is possible. So you can list out the various units for speed. Remember, on the numerator, it should be a distance unit that can be varying from meter, kilometer, centimeter, etc. And on the denominator, it should be a time unit, that is second, minute, hour. Okay. So by putting various units for distance and time, you can uh, get the different units for speed. Now, another for the in the speed, if we have taken that the distance traveled by the object in a definite direction with the magnitude of distance, that is from the value of distance traveled, if we are also considering the direction in which the object is traveling, then that defines the another quantity, that is velocity. The velocity can be defined as if the distance traveled by an object in a definite direction in a unit time is called its velocity. Okay. In speed, we have not considered its direction. But if we are considering a definite direction, then this is very important. Then it is called a velocity of. For a unit motion, the velocity will be constant, like speed. Speed is constant, velocity is also constant, but for changing time, and how can velocity can be changed? See, if distance traveled by the object is varying, then speed can be changed. But in velocity, if distance is same, distance is constant, distance traveled by the object is constant, but the direction is changed, then also the velocity can be changed. Okay. So distance and direction, both it is depending on. Okay. If the distance traveled is same, but its velocity, its direction is changed, then also it is called the velocity is changed. Okay, so direction is very much important. But and for uniform, for a non-uniform motion, the average velocity can be defined as V average is equal to initial velocity u plus final velocity v upon 2. We have two velocities, one initial and one final. Initial velocity is defined as is symbolized as small u, and final velocity is v and divide by 2. Okay, simply the average of the two velocities divide by 2, average of them. That is the average velocity. Speed and velocity have the same symbol v. Okay, only difference is in speed we are not considering its direction, and here we are considering in which particular direction the object is going. Okay, so that defines the velocity. The symbol is same and the units are also same. Speed, the unit is meter per second, and velocity also, the unit is meter per second. Both have the same unit. So read up to this, and still if you have any doubt you can ask me. Thank you.